I'm gonna pick one. Okay, so this is a medium question. I'm gonna do. I'm gonna reset the timer and let's start. Okay. Implement Magic Dictionary. Design a data structure that is initialized with a list of different words. Okay. Provided a string, you should determine if you can change exactly one character in this string to match any word in the data structure. Okay? It sounds like very simple as operation. So we have to implement Magic Dictionary class. You have a constructor, and then we're going to implement build dict method. This can assist the data structure with an array of distinct strings dictionary. I started to losing. Okay. And then we also have to implement another method, search, return true if you can change exactly one character in search word. That's the given argument to match any string in the data structure, otherwise return false. Better look at the example. I'm still not clear what to do. So, um, okay, so first we are given dictionary, this data, and then we're going to create a dictionary. um, we're going to do something, and then um, next we are going to given search word. In this case, it's a hello, and then we're going to search whether hello. If you can change exactly one word. So my question is, this doesn't change any characters to find a match, but it's saying we can change exactly one character. Can we not change it? So this is supposed to be false, but so if we are given exactly the same word, we have to return false. And then if I go to the next example, search hello. So if we change the second H to E, we can have a match in the data structure. So we are supposed to return true and change H to E exactly the same I just described. And then if the search word is hell, um, we are supposed to return false. So changing one character doesn't mean inserting one character. For example, if we insert O after L, it's going to be hello, but it's not what this question is asking. And if you're given LeetCode, so it's likewise, we cannot remove one character to have a match. What we have to do is replace a character with another character. Okay. And then we're gonna have dictionary length gonna be 100. Word size is gonna be 100, and we only have lowercase English letter. Dictionary distinct. That's nice. Search word up to 100. Search word consists of only lowercase English letters. That's clean. Build dictionary will be called only once before search, okay? And at most 100 calls will be made to search. So up to this point, I have no idea to apply any particular algorithm that I can apply to have some kind of optimized way. What I can think about is only the brute force approach. So the brute force approach I can think of is, um, you know, I'm going to create a hash set from this given dictionary, and then a given search word. Um, okay, so the brute force approach is given this one, and let's say I take this one. This is not a good example because it's exactly the same. So this is the replacing case. So let's say um, for given word, I'm going to replace the same place with some other character, for example, I don't know, asterisk. And if the word is going to be the same, um, it means we change exactly one character and then we're going to have the match. For example, if we replace H with the asterisk, it's going to be asterisk ELLO. It's going to be asterisk HLLO. And that's not the same. But if I change the second character to the asterisk, it's going to be H asterisk LLO. And this also going to be H asterisk LLO. And that's going to be the match. And that's also so we can say that to um, so it's actually I don't have to create a hash set for each element. The dictionary array I'm gonna do replacing stuff. So this is very brute force. I'm gonna just take a note for time complexity. Let's say n gonna be length of dictionary array, and m going to be current search word. So brute force, this is gonna take time, going to be O of nm, because for each search word, um, we for each search word we are going to pick one word from the dictionary, and then for each character we're going to replace it. So this is going to be O of nm for every time we do search method. Is it feasible to this question? I don't know. So we are going to have at most 100 calls. So so it's going to be 100 search methods multiplied by um, dictionary length going to be up to 100 dictionary length, and each word at most going to have 100 length. So 100 search word length, and this going to be 1 million. Is it? I don't know. Is it okay? I'm not sure. But this is medium question, so I guess it obviously there should be some kind of time optimized way approach. Maybe I can spend a few more minutes to think about it before coding it. Um, so the bottleneck is um, I think the first bottleneck is um, iteration of dictionary array. That's kind of uh, this this taking a lot of time. And if I follow my intuition at the beginning, I said like hash set. So if I'm going to just follow my intuition and then whether I can make it better. Um, I think that after the brute force, the next step I can think about to make it faster is, for example, like or in log n, which is faster than in log in n. So I think that might be possible if um, this can. Well, let's say we're going to solve this dictionary array, and once we find when we iterating from the left, when we find a current word from the dictionary, the length is longer than current search word. It's not going to be the candidate because even if we replace it, we cannot insert. So it needs to have the same length. So as long as we find the length is longer than current search, I think we can just stop doing it and then just return false. That's going to be a little bit optimization, but I think it's still really helping me maybe at the worst case. For example, like if we have um, the length is this is 5, and if we are given this, we can skip the LeetCode because this is longer than 5. But if we have the dictionary is full of 5 length word, it's going to iterate everything. So it's eventually it's going to be the old and then it's the same thing. Um, can I do something faster? Uh, um, I'm thinking about like if we use hash set, if he's using certain data in hash set, it's going to be the time going to be all 1. If I can take advantage of that kind of approach to check whether a certain thing is in the hash set, I think it's going to be faster, but I have no idea how to do it. Um, mm, well, I mean, for example, like when I build a dictionary array, we can create the hash set, and hash set gonna be just gonna have multiple one word, but replacing each character with the asterisk. And when I search it, we just replace each word with the asterisk, and then whether that new string is in the dictionary hash set, it's gonna be faster. But the dictionary array data set is going to be very huge because for each dictionary word, we are going to have multiple words. Hmm. That's one way to do it. Hmm. How can you do it? Yeah, I can't think about any kind of particular algorithm way. I think it's already 14 minutes, so I think it's better just start coding it and then just wish, well, we're just gonna hope that I'm going to find out some kind of way to do it. So I'm gonna just follow the sorting brute force approach, and then I'm gonna just wish that's going to be help me. So firstly, I'm gonna have dictionary, just initialize with node. And then when we receive dictionary, and we're going to replace with the given dictionary. And as I said, I'm going to sort it. Right. Okay. And then for the search word, for each word, pick the word in self dictionary. Okay. And then for each length of the search word, um, um, I'm going to replace each word I to be asterisk. We cannot change it. So actually, I don't have to replace it with asterisk. I just want to check just removing particular word and then whether the rest of the stuff is going to be the same. So if the word up to I is equal to search word up to I, and also just removing it means pick the word I plus 1, and the rest of the stuff is also equal to search word. Skipping one word, the rest of the stuff. And if this is the same, I can return true. And nothing happened, I have to return false. Excuse me. And what I have to check is if the length of, as I said, dict word is bigger than the length of search word, we just immediately return false because we couldn't find it. And also, if smaller, we can also do something. So dictionary word. So this length is smaller than search word. This means that we can basically skip this dictionary word. So we just skip this dictionary word. And when it's the same, we can, length of it will be the same, we can actually do this operation. So I think this should be the working brute force. I just ran it for the test case, and sadly it's not working. But it looks like it's just a typo, so it's just gonna search word. So it worked for this little test case, but obviously this is brute force, so I don't think this is gonna work for all the tests, all the cases. Just making a mistake. So let's say we have this one, be given hello, and okay, so we have hello is going to be hello by replacing it. So that's supposed to be true, but I'm returning false. That's not correct. So we definitely created this dictionary, and then length's going to be the same. So for each search word, we're doing something. And I think this is, when I sort it, I think this is going to start with A1, so HA. So if this is 0, oh yeah, this is just typo. So this, like this, okay. Oh, we started not working, okay. Oh, so, what? I don't know why that was working before, but Oh, right. So because I need to have one more condition, current word is different. So this is actually uh, not complete. So I'm gonna just make it multiple lines for the readability. So this gonna be the same, but current word should be different. So picked word I is different from search word I. And I need to add that. So this gonna work for little cascade, and if I'm gonna run everything, it didn't work. So why is that? So we give A, and obviously B should be. Yeah, it should. It should be. I should return true. So why is that? So the length is gonna be the same. Let's say this is starting from 0. So this is empty, and this is gonna be uh, uh, this is +2, right? Because no, this is 1. Okay, so it's already 21 minutes. I really hate, I'm very slow coding. So if this is I equals 0, this is going to be empty. And then this is going to be also empty. And current word 0 is different. So I'm supposed to return true. I don't know why it didn't work. Maybe I'm gonna start printing and then just probably debugging. So I'm gonna copy this test case right here, right here. And I think what I'm going to do is, first I wanna print search word. Search word is given by search word, right? And then why I'm returning false. So maybe here I'm going to print out dict word, and so the problem is here. Search word B. This should work. No. For one, no. For search word, no. Search word A, I want to run dict word 3 times, but this is only just 1. I might made some kind of stupid mistake. Why is that? So I'm supposed to have self dictionary. Am I doing like very like basic mistake? Self dictionary. We obviously have. Right. Okay. Yeah. If I sort, just A comes first, and then I'm gonna just stop there. So I'm not reaching B. So sorting algorithm is just wrong. So sort by length. So he should be lambda function. We given something, and we're going to order by length of this word and also current word. So it's going to be A B A B. I mean A B A B. I guess. So A, B, A, yes. So it worked for this test case. But I think it's still the brute force. I don't think this will work for all the cases. I suppose all the standard output, right? Yeah, so we can run for all the cases. I solved? Okay. Um, I don't know why. I don't know what the intention of this question. It's obviously it was a brute force, but I was still able to pass all the test cases. Um, I don't know. I didn't. I mean, I did a little optimization, but it just for the worst case, it's also still the same time complexity as brute force. Um, I mean, the catchy part was sorting was kind of customized, but basically it's just a for loop and a little bit tricky if condition. Is that what this question is asking about? I pass it, but if there's other, I mean, I can check the solution later to see. I feel like there should be obvious optimized way because I'm kind of below this distribution. So I guess there should be a better approach to do this kind of search operation. But um, I guess I guess maybe better approach would be using some kind of different. Uh, there's another distribution using more memory. So I think before search, at the build dictionary, I guess you're going to create a different dictionary data structure. So searching going to be faster. So I think that should be approach for this time distribution and this space distribution. But basically I pass it, but I can take the better approach later.